Okay, so here are the four problems that you have to solve without possibly using the unit circle. It's using the same procedure that we've covered, but I know some of you prefer to use the unit circle for the other problems, which is fine. But there are cases where you can't use a unit circle. So the first problem, do the same thing that you would have done. You're going to solve for the sine of x, and the sine of x is negative 1/5. So the question is what values, and we'll say all solutions here, not just between 0 and 2 pi. So what we're going to do is we're going to find the solutions between 0 and 2 pi, and then we're going to add 2 pi n to the solutions. So this is problem number one. Step one, remember our four-step process here. Step number one is which quadrant. Now all this relies upon is what the signs are. So it's the sign, meaning SIGN. So which quadrants is the all students take calculus, not all take student calculus. All students take calculus. And we're dealing with the sine function. So the sine is positive in the first and second quadrants. It's negative in the third and fourth quadrants. So the answer is Q3 and Q4. Okay, step number two. Find the reference angle. It's going to be equal to the inverse sine of the absolute value of negative 1/5. So this is not square root of 2 over 2. It's not square root of 3 over 2, and it's not 1/2. So we can't use the unit circle. So let's make sure our calculators are in radians. So we're going to do the arc sine of 1/5. Take the absolute value, so we get 1/5. And so the reference angle is 0.2014 radians. And we're going to divide that number by pi. So we get 0.0641 pi radians. So that's in the first quadrant. Reference angle is always in the first quadrant. Step number three is we look at the quadrants and we write down the appropriate equation. So in the third quadrant, the angle is equal to pi plus the reference angle. So we get pi plus 0.0641 pi, which is 1.0641 pi. Third quadrant solutions are always so easy because you just add. Then your fourth quadrant solution is 2 pi minus the reference angle. So we take 2 pi, subtract 0.0641 pi. So what we're doing here is we're taking 2 and we're subtracting 0.0641, and we're multiplying that difference by pi. So 2 minus 0.0641 is 1.936 pi. So that's my fourth quadrant solution. There's my third quadrant solution. And then to find all solutions, I take my third quadrant solution and I add 2 pi times n. And for my I take my fourth quadrant solution and I add 2 pi times n, where n is a integer between negative infinity and positive infinity. And we'll double check this, as I always do with these problems, especially since I made this up, so I'm really going to double check it. So that's the function I'm going to do is the sine of x. Well, I could go back to my original function, couldn't I? So my original function would be sine of x plus 1, so that's y. I guess I'm going to have to So we go from 0 to 2 pi, and it's the sine of x. What was it, 5? 5 times the sine of x plus 1 equals y. Graph it. So there it is. 5 sine x plus 1 equals y. So I'm looking for the x-intercept. And now I can go back to my answer. So there's my answer. So let's find this. Oh, that's my reference angle, so I need to go one more page. There we go. So this intersection should be 0.06 pi, which it is, and this one should be 1.93 pi. And if I'm going to zoom in. If I zoom in a couple times, put my cursor there, I'm going to get 1.0641, which is exactly what I'm looking for. I'm just fixing this before I move on. So I forgot to fix the y. So that was from -5 to +5. So there we go. Okay. So that's problem number 1. Number 2. So the first one was just a simple solving equation here. Number 2, I have to factor it. So I'd have 4 cosine of x, and I'd have 3 cosine of x. So when I multiply 4 times 3, I get 12. And the difference, 4 minus 3, is 1. So you can say I got 1, but it's -1. So I need to put a -1 here and a +1 there. And that all equals 0. So double check here. 12 cosine squared plus 3 cosine minus 4 cosine gives me -1 cosine. +1, -1. Okay. So the solutions are when 4 cosine x plus 1 equals 0, or the cosine of x equals -1/4. And the second group of solutions is when 3 cosine x minus 1 equals 0, or the cosine of x equals 1/3. And I'm going to get 2 solutions from each one of those. So we will do the steps here. Step 1, which quadrant? Well, all students, can't seem to get that. All students take calculus. ASTC. And we're dealing with the cosine. So it's positive in the first quadrant, positive in the fourth quadrant, negative in the second and third. So this -1 will give me a third and second quadrant solution, and this one will give me a first and fourth quadrant solution. Step number 2 is to find the reference angle. So here I'm going to take the inverse cosine of the absolute value of -1/4. Over here I'll take the inverse cosine of the absolute value of 1/3, and I'm just going to give you the answer. You can plug it into your calculator. So you get the inverse cosine of 1/4, and that's 1.318, and I'm going to divide by pi. So here I'll get 0.4196 pi. And if I take the inverse cosine of 1/3, I'll get 1.231 divided by pi. So divided by pi, I get 0.3918 pi. So those are my reference angles. And so my second quadrant solution, x, is going to be pi minus my reference angle. So that's pi minus 0.4196 pi. And so if I take 1 minus 0.4196, I'll get 0.580 0.04 pi. So that's my second quadrant solution. My third quadrant solution is pi plus the reference angle. So that's pi plus 0.4196 pi, which I can do in my head. You should be able to do in your head too. It's 1.4196 pi. So that's my third quadrant solution. And then I've got my first quadrant solution, which is always easy because it's just equal to the reference angle. So my first quadrant solution is 0.3918 pi. And then my fourth quadrant solution is 2 pi minus the reference angle. For this group, the reference angle is 0.3918 pi. So I'm going to get x is equal to 2 pi minus 0.3918 pi. So what I'm doing here is take 2 minus 0.3918, and I'll get 1.6082 pi. So those are my 4 solutions between 0 and 2 pi, and then I can do my, step number 4 is I take my solutions and I add 2 pi into them. So my first quadrant solution, let's start with that. That's 0.3918 pi plus 2 pi n. My second quadrant solution is this one over here. It's 0.5804 pi plus 2 pi n. My third quadrant solution is down here. So it's 1.4196 pi plus 2 pi n. My fourth quadrant solution is 1.6082 pi plus 2 pi n. Then define n. As we always do. And so that is, that's it. Now I'm going to go back and I'm going to check out these answers. And what I'm again going to do is I'm going to go back to my original equation and I'm going to plug that in before I do any factoring, just to show you the factoring doesn't affect anything. It just gives me the right solution. So I have 12 times the cosine of x squared, 12 cosine squared x minus cosine of x minus 1 equals y, 0 to 2 pi. I should have 4 solutions, which I do. 1, 2, 3, 4. And because I've got them decimals of pi, I should be able to easily verify these things. So you can see here's my 4 solutions. So here's the graph. The first one should be 0.392. 0.39 pi, there we go. The second one should be 0.5958. You can see it's 0.58 pi. That's the second quadrant solution right there. The third quadrant solution is 1.42. That's that one. And the fourth quadrant solution is 1.61, which is that solution. And let me just zoom out in the y direction. You see it. It's a sine function. And because it's shifted vertically like this, I mean, it's not a sine, it's a sine-like function, and it, it has, but it's shifted vertically, so it intersects. The intersections are pretty close together. Okay, the next one is a tangent function, so I wanted to do some other trig function besides sine or cosine. So again, this one, pretty simple. You can just solve for tangent, and you get the tangent of x is equal to 7/4. So we add 7 to both sides, divide by 4. Again, the usual culprits for unit circle are square root of 3 over 3, 1, and the square root of 3, and that's definitely not any one of those. Okay, step 1. Which quadrant? All students take calculus. This is the tangent. Positive in the first quadrant, positive in the third quadrant, negative in the second and fourth quadrants. So because this is positive, it's going to have a first quadrant and a third quadrant solution. Step number 2, find the reference angle. It's going to be the inverse tangent of the absolute value of 7/4. So again, I'm going to give you the answer. You can confirm. So take the inverse tangent of 7/4, and we get, I'm going to read it out, 1.0516. So if we divide that number by pi, we'll get x prime is equal to 0.3347. Turns out that's pretty close to pi over 3, but it wasn't meant to be. 0.3347 pi radians. Okay, 7/4, 1.75, square root of 3 over 2. Is that right? Square root of 3, just the square root of 3. Square root of 3 is 1.732. So they're pretty close to each other. What I'm doing is comparing the square root of 3 versus 7/4. Just turned out that it was pretty close to the same thing. Okay, so that's the reference angle. Inverse tangent, because I have a tangent here. Step 3 is to find the solutions. So there's a third quadrant, first quadrant solution and a third quadrant solution. So Q1, the angle is equal to the reference angle, or 0.3347 pi radians. Now I could just use the first quadrant solution and add n pi, or I can find the third quadrant solution so that I'm consistent. I use the same process. So the third quadrant solution is you take pi plus the reference angle. So you get 1 pi plus 0.3347 pi, so you get 1.3347 pi radians. So that's my third quadrant solution. So there's two ways of doing this. To get step 4, we'll use the same procedure here as the sine and cosine, and then we'll do it just using the special case for tangent. So my two solutions are, there's my first quadrant solution. So I'd say x is equal to 0.3347 pi plus 2 pi n. And the third quadrant solution is 1.3347 pi plus 2 pi n, where n goes between integers between negative infinity and positive infinity. So that was one way you can do it. Or you could just take your first quadrant solution, 0.3347 pi, and add pi n. Instead of 2 pi n, add pi n, where n still goes by integers from negative infinity to positive infinity. So this solution here, 1.3347 pi, would be when n equals 0 in this case. If I had n equals 1 in this second case, I'd get 1.3347 pi. So either one of this is going to be fine with me. Okay, so let's check see if this thing actually is true or not. We're going to check this solution here, step 3, because we're just going to plot. So we have 4 tangent of x minus 7 equals y. So let's type that in. 4 tangent of x minus 7 equals y. And let's go from negative 5 to positive 5. Just need to have 0 in there someplace. And you see there's two solutions. And the two solutions should be 0.3347 pi. That's that right there, 0.34 pi. And this one is the second solution, which is 1.34 pi. Okay, and one more. This one is a multiple angle problem. Just want to show you how to do that. So just like in previous things, we define a new variable. Theta is 2x. So we get the cosine of theta is equal to negative 0.57. So step 1, for theta, which quadrants? All students take calculus. Cosine. Positive in the first and fourth quadrants, negative in the second and third. So because this is negative, we're going to have a second quadrant and a third quadrant solution in terms of theta. So second step, for theta, we calculate the reference angle. Theta is equal to the inverse cosine of the absolute value of negative 0.57. So again, when you take the absolute value, you get positive 0.57. So we're going to take the inverse cosine 0.57, which is 0.964, and we're going to divide that by pi, and we'll get 0.3069 pi. So that's my reference angle in terms of theta. And then I do my two solutions. My quadrant 2 solution, theta is equal to pi minus theta prime. So we get theta equals pi minus 0.3069 pi. So I'm taking 1 minus that. 1 minus 0.3069 is 0.6931 pi. So that's my second quadrant solution, and my third quadrant solution is the angle is pi plus my reference angle. So I get pi plus 0.3069 pi, which is a piece of cake, 1.3069 pi. So that's my third quadrant solution. Now, step 4 is I do the multiple, all my solutions here. So I do use the same process. I say theta is equal to 0.6931 pi plus 2 pi n. And theta is my third quadrant solution, 1.3069 pi plus 2 pi n. So now I do this substitution for here. So theta is 2x, or x equals theta over 2. So what I'm going to do is I'm going to divide all this by 2. So I'll get x is 0.6931 over 2 pi plus 2 pi n over 2. And we'll just plug that in there. 0.6931 divided by 2 is 0.3466 pi plus pi n. So that's the first one. So let's put a little square around that. And then the second one is 1.3069 pi divided by 2 plus 2 pi n divided by 2. So I get x. So if we take 1.3069 divided by 2, we'll get 0.6535 pi plus pi n. So that's my second solution. So those are my two solutions, but those are between 0 and pi because theta is equal to 2x. So theta went from 0 to 2 pi, so x goes from 0 to pi. So this would be correct. If I wanted to just double check and make sure I did the solution right, I'd end up with 4 solutions between 0 and 2 pi. I'd have the solutions here with n equals 0. So that's my first case, 0.3466 pi plus 0 pi. Then I'd have another solution here where I'd add pi. So it's easy again because pi plus this is, you just add the coefficients, 0.3466 plus 1, so I get 1.3466 pi. So that's my n equals 1 solution there. And then I go to the next one, which is 0.6535 pi. And then, so this was n equals 0, this was n equals 1, this is n equals 0, this is n equals 1. So again, I add 1 to that, 1.6535 pi, sorry. 635 pi, this is 1.6535 pi. And so all of these are between 0 and 2 pi, because you see I have 1.6, which is less than 2. So now if I plot that original function, and I'll see if I did it right or not. So the original function, where is it here? Somewhere. I had it. I know it's here somewhere. Oh, this one here, cosine of 2x. Yeah, that's the one I wanted. So what I'm actually going to plot is y equals cosine of 2x plus 0.57. Okay, and I'm going to find out where that intersects. And it should be in the 4 places that I figured it out. So I get the cosine of 2x plus 0.57. Between 0 and 2 pi, graph it. See this 4 intercepts, which are my 4 solutions. And I'm going to go to the last page here, which is that one. So the first one should be 0.34, which it is. The second one should be 0.6566. That's that one. The third one should be 1.35, and the fourth one should be 1.65. So you can see that those are all these are the solutions for n equals 0, and these are the solutions for n equals 1. It all comes back to, because I've got the cosine of 2x is this. So what this does is it gives you a horizontal shrink, a factor of 2. So instead of getting 2 solutions, you get 4 solutions. If it was 3x, I'd have 6 solutions. If 4x, I'd have 8 solutions between 0 and 2 pi.